May 19th, 1944, 14:33 hours. Northwest of Bougainville, Solomon Islands. Commander Walton Byron Pendleton stood on the bridge of the destroyer escort USS England, his hands gripping the rail as sonar reported solid contact at 1,600 yards. Below the surface of the Pacific, Captain Lieutenant Takeuchi Yoshitaka commanded the Japanese submarine I-16, a veteran of 9 war patrols, now carrying 75-pound bags of rice to starving Japanese garrisons. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Pendleton gave the order. The Hedgehog launcher forward of the bridge erupted in sequence, 24 projectiles arcing into the humid air in less than 2 seconds. The submarine commander had perhaps 30 seconds from the moment he heard England's propellers to the moment the first Hedgehog bomb struck his pressure hull at 130 feet depth. There would be no evasion, no last-minute dive, no emergency surfacing. The mathematics of anti-submarine warfare had fundamentally changed, and German U-boat tactics perfected over 5 years of Atlantic combat had become obsolete. What I-16's commander could not know in those final seconds was that the weapon destroying his submarine represented a revolution that had already devastated the German U-boat force in the Atlantic. The Hedgehog mortar, with its deceptively simple design and devastating contact fuses, had transformed submarine hunting from a war of attrition into a war of precision. The weapon that gave attacking ships perhaps 30 seconds to kill a submarine had been operational for 2 years, and its effects had helped turn the tide of the longest battle of World War II. The Battle of the Atlantic was the campaign that truly frightened Winston Churchill. While the public watched tank battles in North Africa and air raids over Britain, Churchill understood that Britain's survival depended entirely on merchant ships crossing 3,000 miles of ocean patrolled by German U-boats. Every gallon of fuel, every artillery shell, every soldier, every ounce of food Britain needed to continue fighting had to cross the Atlantic. The German Kriegsmarine understood this vulnerability perfectly. Admiral Karl Dönitz had calculated that sinking merchant ships faster than the Allies could build them would strangle Britain into submission without ever invading the island. In 1942, Dönitz nearly succeeded. German U-boats operated in coordinated wolf packs, intercepting convoys through radio coordination and overwhelming escorts through sheer numbers. Between January and June of 1942, U-boats sank nearly 500 ships in American waters alone. The monthly toll of Allied merchant ships peaked at 124 vessels in June 1942. British fuel reserves dropped to critically low levels. Food rationing tightened beyond what British civilians had endured in 1941. Churchill's private calculations suggested that Britain had perhaps 6 months of reserves remaining if losses continued at this rate. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The weapon that would help change this equation was being tested in the cold waters off Northern Ireland. The problem confronting Allied anti-submarine forces was fundamental. Sonar, the acoustic detection system that had revolutionized submarine hunting, possessed a critical blind spot. When an escort ship approached within 200 yards of a detected submarine, the time between sonar pulse and echo became too short for human operators to distinguish. The submarine effectively vanished from detection at precisely the moment when depth charges needed to be deployed. Worse, depth charges themselves were profoundly inefficient weapons. Rolled off the stern of attacking ships, they sank slowly through the water while the submarine took evasive action. The attacking ship had lost sonar contact and could only guess where the submarine had maneuvered. Depth charges detonated at preset depths through hydrostatic pressure fuses, creating powerful shock waves that could damage or destroy submarines. But the explosive force dissipated rapidly through water, requiring near-miss proximity to inflict fatal damage. Statistics compiled by British naval intelligence revealed the brutal arithmetic. During the first years of the war, only 5% of all depth charge attacks successfully destroyed submarines. Under normal combat conditions, this figure dropped to 3%. The German submarine force understood these limitations intimately. U-boat commanders developed elaborate evasion techniques for the critical minutes after losing contact with attacking escorts. Sharp turns at high underwater speed, emergency dives to depths beyond typical depth charge settings, sudden surfacing attempts, all calculated to exploit the blind period when escorts had lost sonar contact. Many U-boats survived hundreds of depth charge attacks. U-427 survived 678 depth charges dropped against it in April 1945, a testament to both the resilience of German submarine construction and the fundamental limitations of depth charge warfare. The solution required forward-thinking weapons that could attack submarines while ships maintained sonar contact. The Fairley mortar, tested secretly aboard HMS Whitehall in 1941, attempted this approach. It failed catastrophically, proving mechanically unreliable and tactically unsound. But the principle of forward-firing anti-submarine weapons remained viable. If projectiles could be launched ahead of the attacking ship while sonar still held contact, submarines would have drastically reduced time to evade. The Directorate of Miscellaneous Weapons Development, known colloquially as the Wheezers and Dodgers, tackled this challenge. This unconventional British Admiralty department specialised in developing unorthodox weapons for situations where conventional approaches had failed. Among the DMWD staff was Lieutenant Commander Neville Shute Norway, better known by his pen name Neville Shute, the novelist who would later write On the Beach and A Town Like Alice. The department's unofficial motto reflected its approach to seemingly impossible problems. Where conventional wisdom failed, improvisation might succeed. Lieutenant Colonel Stuart Blacker had developed the spigot mortar principle in the interwar years. Unlike conventional mortars that used barrels to contain propellant gases, spigot mortars featured a fixed rod, the spigot, that fit inside a hollow tail on the projectile. The propellant charge, mounted on the weapon itself, detonated against the projectile, launching it from the spigot. This design allowed a single launcher to fire projectiles of different sizes and weights without modifying the weapon. Blacker's design had already been adapted for the Blacker Bombard infantry mortar and would later become the basis for the PIAT anti-tank weapon. The DMWD adapted Blacker's spigot mortar principle to create a multi-barreled launcher that could throw 24 projectiles ahead of an attacking ship. The resulting weapon, mounted on a steel cradle forward of the bridge, featured rows of spigots angled to create a circular impact pattern. The projectiles themselves were elegantly simple. Each bomb weighed 65 pounds, 7.1 inches in diameter, containing 35 pounds of Torpex explosive. Torpex, a mixture of 42% RDX, 40% TNT, and 18% powdered aluminum, packed 50% more explosive power than TNT alone. The critical innovation, it was the contact fuse. Unlike depth charges that detonated at preset depths regardless of whether they struck anything, Hedgehog projectiles would only explode upon direct impact with a solid object. This feature addressed multiple tactical problems simultaneously. If the pattern missed the submarine entirely, the silent projectiles would sink harmlessly to the ocean floor. Sonar contact would remain undisturbed by explosions. The attacking ship could immediately launch another attack without waiting for disturbed water to settle. But if even one projectile struck the submarine's pressure hull, the resulting explosion would likely trigger sympathetic detonation of nearby projectiles, creating a concentrated blast far more destructive than the cumulative effect of distant depth charge explosions. The geometry of Hedgehog attack was coldly efficient. The 24 projectiles, fired in pairs 1/10 of a second apart, landed in an elliptical pattern measuring approximately 140 feet by 120 feet at a range of 200 yards ahead of the attacking ship. The projectiles sank at 23 feet per second. A submarine at 200 feet depth would be struck within 9 seconds of the projectiles entering the water. From the moment a U-boat commander heard the distinctive sound of a ship's propellers overhead to the moment Hedgehog projectiles began detonating against his hull, perhaps 30 seconds elapsed. 30 seconds to recognize the attack, order evasive maneuvers, execute those maneuvers, and hope the pattern missed. Traditional U-boat tactics assumed several minutes of warning before depth charges detonated. Submarine commanders could hear depth charges being rolled off the stern. They could track the approaching ship through hydrophones. They had time to maneuver, to go deep, to attempt escape. Hedgehog eliminated that luxury. The projectiles appeared overhead with minimal warning, striking from above before evasive, an action could be completed. The cushion of water that normally dissipated depth-charge shock waves now worked against the submarine. When a Hedgehog projectile detonated against the pressure hull, the water cushion was on the opposite side, actually increasing the explosive shock transmitted into the submarine's interior. The weapon entered service in 1942. HMS Westcott carried the prototype launcher during trials in 1941, but no submarine kills were recorded until November 1942, after 100 ships had been equipped. Initial success rates were disappointing, approximately 5%, barely better than depth charges. The problem was not the weapon but the crews using it. Naval commanders and their crews had spent years perfecting depth charge tactics. Hedgehog required entirely new approaches, new instincts, new trust in a weapon that often produced no dramatic explosions to indicate near misses. The Royal Navy launched Hedgehog attacks so rarely in early 1943 that the Admiralty issued a directive requiring captains to report why they had not used Hedgehog when underwater contacts were detected. The responses revealed crew inexperience and low confidence in the new weapon. Depth charge attacks, even unsuccessful ones, created massive explosions that boosted crew morale and potentially demoralized submarine crews. Hedgehog misses were discouragingly silent. Crews couldn't tell if they had frightened the enemy or forced evasive maneuvers. The psychological difference mattered enormously in the brutal mathematics of anti-submarine warfare. The turning point came when DMWD officers travelled to Londonderry, Northern Ireland, where convoy escort vessels were based. They conducted ship-wide training sessions, explaining Hedgehog tactics and presenting documented examples of successful attacks. More critically, they explained the weapon's advantages. Hedgehog allowed ships to approach submarines slowly and quietly, maintaining sonar contact throughout the attack. The attacking ship didn't need to accelerate to high speed, pass over the submarine, and roll depth charges. Instead, escorts could maintain steady approach speeds, fire Hedgehog while still holding sonar contact, and observe results immediately. If the attack missed, another could be launched within minutes without losing contact. After comprehensive training, Hedgehog kill rates improved dramatically. By the end of the war, statistics showed that on average, 1 in every 5 Hedgehog attacks resulted in a submarine kill. The ratio was 5.7 attacks per kill compared to 60.5 attacks per kill for depth charges. This tenfold improvement in efficiency meant fewer attacks required to destroy submarines, faster convoy protection, and more efficient use of escort vessels. The weapon's impact extended beyond simple kill statistics. The mathematics of submarine warfare depended on exchange rates. If German U-boats could sink merchant ships faster than the Allies could build them while surviving longer than Germany could replace U-boats, the Atlantic battle would be won. Hedgehog fundamentally altered this equation by making each anti-submarine attack exponentially more lethal. May 1943 became known as Black May among German submariners. The U-boat force suffered 43 submarines lost, representing 25% of operational boats. This catastrophic loss rate exceeded anything previously experienced. Admiral Dönitz, shocked at the sudden reversal, temporarily withdrew U-boats from North Atlantic convoy routes. Multiple factors contributed to Black May. Improved radar allowed aircraft to detect surfaced submarines at night. Increased numbers of very long-range aircraft closed the mid-Atlantic air gap, where submarines had previously operated with relative safety. Better intelligence from breaking German naval codes allowed convoys to evade submarine patrol lines, but Hedgehog played a significant role. Escorts equipped with the new weapon demonstrated dramatically improved kill rates precisely when submarine losses spiked. The weapon gave escort commanders confidence to aggressively prosecute sonar contacts, knowing that each attack had reasonable chances of success. The psychological impact on U-boat crews was profound. Survivors of Hedgehog attacks described a terrifying new reality. Depth charge attacks, while dangerous, followed predictable patterns. Submarine crews could hear depth charges rolling off the attacking ship's stern, They could estimate depth settings and timing. They knew when to brace for explosions. Hedgehog attacks provided no such warning. The first indication was often the devastating impact of 35-pound charges detonating directly against the pressure hull. Some crews never heard the attack coming. Others heard propellers overhead and then immediate explosions, with no intervening period for evasion. German naval intelligence eventually identified the new weapon. Interrogations of Allied prisoners, examination of unexploded ordnance recovered from shallow waters, and analysis of attack patterns all pointed to forward-throwing anti-submarine weapons. But identifying Hedgehog and countering it were different challenges entirely. U-boats had no effective defense against weapons that struck from above with minimal warning. Traditional evasive maneuvers assumed time to execute. Hedgehog eliminated that time. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Attempts to develop countermeasures largely failed. Submarine commanders tried maintaining greater depths to increase the time between projectile launch and impact, but deeper operations reduced periscope effectiveness and complicated attacks on surface targets. Some commanders attempted high-speed evasive maneuvers the moment they detected attacking ships, hoping to clear the impact area before projectiles arrived. But escorts using sonar could track these maneuvers and adjust aim accordingly. The fundamental problem remained. Once a ship achieved solid sonar contact at close range, submarines had insufficient time to escape the Hedgehog impact pattern. The weapon's effectiveness was demonstrated most dramatically by USS England in the Pacific. Operating with sister ships USS George and USS Raby in May 1944, England hunted Japanese submarines deployed as a scouting line north of the Admiralty Islands. American codebreakers had intercepted and decoded Japanese naval messages, revealing submarine positions and missions. The 3 destroyer escorts were vectored to intercept. On May 19, 1944, England detected I-16 during calm, sunny weather. The first Hedgehog attack at 13:41 hours missed. A second attack scored 1 hit at 130 feet depth. The third attack missed because estimated depth was incorrect. I-16 outmaneuvered a fourth attack. The fifth Hedgehog attack at 14:33 resulted in 4 to 6 detonations, followed by a massive underwater explosion that lifted England's stern and knocked crewmen off their feet. Debris began floating to the surface 20 minutes later. The following day, a 3 by 6 mile oil slick marked I-16's grave. 3 days later, England's hunting group detected RO106 on radar at 0350 hours on May 22. USS George saw the submarine dive when illuminated by searchlight and missed with a Hedgehog attack. England regained contact at 0425, missed with 1 attack, and scored at least 3 detonations on the second attack at 0501. A large underwater explosion followed as England prepared a third attack. Heavy oil slick and debris appeared after sunrise. The following day, May 23, USS Raby detected RO104 at 0600 hours. Raby and George missed with 8 Hedgehog attacks over 2 hours. England took over at 0834, scoring 10 to 12 detonations on her second attack. Breaking up noises followed, then a major explosion 3 minutes later. Debris and oil surfaced at 10:45. At 0120 on May 24, George detected RO116 on radar. England made sonar contact at 0150 and scored 3 to 5 detonations on the first Hedgehog attack at 0214. Breaking up noises were not followed by the massive explosions noted on earlier sinkings, but oil and debris confirmed the kill after sunrise. On May 26, while England's group was returning to Manus Island for resupply, USS Raby's radar detected RO108 at 23:03 hours. England scored 4 to 6 Hedgehog hits on her first attack. The submarine went down with all 53 crew. The final kill proved most difficult. American codebreakers decoded a May 20th message revealing Japanese submarine patrol dispositions. RO105, carrying the commander of Japanese Submarine Division 51, had been maneuvering elusively since May 30th. Multiple destroyer escorts attacked with Hedgehogs throughout May 30th and into May 31st, without success. Over 20 Hedgehog attacks missed during a brutal 25-hour hunt. Commander Hamilton Haynes, the escort group commander, finally sent the message that would become legend. "Oh hell, go ahead, England." England's Hedgehog attack at 07:36 on May 31st scored 6 to 10 detonations. A major explosion followed at 07:41. Oil and debris fountained to the surface. RO-105 went down with all 55 hands, including Captain Ryonosuke Kato, the division commander. 6 Japanese submarines destroyed in 12 days. This anti-submarine warfare performance was never matched in World War II. Admiral Ernest King, Chief of Naval Operations, assured Commander Pendleton, "There'll always be an England in the United States Navy." That promise was fulfilled on October 6, 1960, when guided missile frigate DLG-22 was assigned the name England. USS England received the Presidential Unit Citation for her unprecedented achievement. The weapon that made this possible represented British ingenuity applied to an American-built destroyer escort operating in the Pacific against Japanese submarines, using tactics perfected against German U-boats in the Atlantic. Hedgehog's success demonstrated how technological innovation, properly deployed with adequate training, could transform combat effectiveness. But the weapon's development and deployment also illustrated the institutional resistance that often greets revolutionary technology. When Hedgehog first entered service, many naval commanders remained skeptical. The Royal Navy's culture emphasized aggressive action. Depth charge attacks, even unsuccessful ones, demonstrated aggressive intent and maintained crew morale through dramatic explosions. Hedgehog's quiet misses seemed passive by comparison. Some commanders argued that depth charge attacks had psychological value even when they missed, rattling submarine crews and potentially forcing them to break off attacks. This argument ignored the fundamental mathematics. Psychological impact meant nothing if submarines survived to attack convoys. One Hedgehog kill prevented future attacks that might sink multiple merchant ships. The cold arithmetic of tonnage warfare favored weapons with higher kill ratios, regardless of their psychological effects. As training improved and success stories circulated through the fleet, resistance diminished. Commanders who had initially avoided using Hedgehog began requesting priority installation on their vessels. The Atlantic battle statistics from 1943 onward illustrated Hedgehog's cumulative impact. Allied merchant ship losses dropped from 124 ships per month in June 1942 to just 4 ships per month in June 1943. Multiple factors contributed to this dramatic reversal: more escort vessels, improved radar, better intelligence, increased air coverage, all played roles. But Hedgehog's tenfold improvement in attack effectiveness significantly increased the lethality of every escort vessel carrying the weapon. German U-boat losses rose correspondingly. From 1 submarine lost per month in January 1942, losses climbed steadily, peaking at 37 submarines in May 1943. Nearly every month after May 1943, the Allies sank more U-boats than Germany sank Allied cargo ships. The tonnage war's arithmetic had reversed. Germany was losing submarines faster than new boats could be built and crews trained. Allied merchant ship production far exceeded losses. The psychological transformation of U-boat crews paralleled the statistical decline. Early war U-boat veterans described their service with confidence bordering on arrogance. They hunted convoys aggressively, surfaced brazenly, operated with the assurance that depth charge attacks were survivable. By 1944, this confidence had evaporated. U-boat crews sailed knowing their chances of survival were poor. Approximately 75% of U-boats that sailed on patrol after mid-1943 never returned. 28,000 German submariners died during the war. 738 U-boats were destroyed. The weapon that contributed to this transformation was remarkably simple in concept. 24 projectiles, fired ahead of a ship, detonating on contact. No sophisticated electronics, no complex fire control systems, no advanced materials. The genius lay in recognizing that forward-firing weapons maintaining sonar contact throughout the attack would fundamentally alter anti-submarine warfare dynamics. That recognition, combined with Lieutenant Colonel Blacker's spigot mortar design and the DMWD's unorthodox development approach, produced a weapon that multiplied escort effectiveness without requiring revolutionary new ships or dramatically increased escort numbers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The production and deployment of Hedgehog illustrated Allied advantages that extended beyond any single weapon system. British design, American manufacturing capacity, shared intelligence, coordinated tactics, all integrated into effective anti-submarine operations. When HMS Westcott tested the prototype in 1941, American shipyards were already preparing to manufacture Hedgehog systems for installation on hundreds of destroyer escorts. The Mark X Hedgehog became standard equipment on American destroyer escorts by 1944. American production streamlined installation and reduced costs while maintaining the weapon's effectiveness. The contrast with German submarine development was instructive. Germany's Type 21 submarine, introduced in 1945, represented genuine technological advancement. Streamlined hull design, increased underwater speed, enhanced battery capacity, all made the Type 21 potentially superior to earlier U-boats, but only 2 became operational before Germany's surrender. Complex design, material shortages, Allied bombing of manufacturing facilities, and chaotic logistics prevented mass production. German engineering excellence produced remarkable prototypes that arrived too late and in too few numbers to affect the war's outcome. Allied development philosophy emphasized incremental improvements to proven designs, manufactured in quantity using standardized components. Hedgehog exemplified this approach. The weapon was not revolutionary in its components. Spigot mortars existed before the war. Torpex explosive was derived from existing compounds. Contact fuses were well-understood technology. The innovation lay in combining these elements to solve a specific tactical problem, then manufacturing the result in quantities sufficient to equip entire fleets. British destroyer escorts and corvettes, American destroyer escorts, even some Allied destroyers received Hedgehog installations. By war's end, hundreds of vessels carried the weapon. This proliferation meant that German U-boats faced Hedgehog-equipped escorts throughout the Atlantic, in the English Channel, in Mediterranean approaches, anywhere Allied convoys sailed. The tactical advantage wasn't limited to a few elite anti-submarine groups. It became standard capability across entire escort fleets. The weapon's simplicity contributed to its widespread adoption. Installation required mounting the launcher cradle on the foredeck, running firing circuits to the bridge, and storing projectiles in magazines. No specialized hull modifications, no complex fire control systems requiring extensive crew training. Experienced depth-charge crews could learn Hedgehog operations within days. Mechanical reliability was good despite the weapon's relatively crude construction. Salt spray and rough seas occasionally caused electrical firing failures, but the weapon generally performed reliably in conditions that would have disabled more sophisticated systems. Hedgehog projectiles themselves were rugged devices. The contact fuse mechanism was mechanically simple: a firing pin, held back by a safety mechanism during launch, armed automatically after the projectile entered the water. Upon striking a solid surface, inertia drove the firing pin forward into the detonator, triggering the Torpex charge. The entire mechanism was designed to withstand the shock of launch and the pressure of rapid descent through water. Failure rates were acceptably low, typically less than 10% of projectiles failing to detonate on impact. The 35-pound Torpex charge, while small compared to 300-pound depth charges, proved devastatingly effective when detonated directly against a submarine's pressure hull. The explosion punched holes 3 to 4 inches in diameter through the steel plating. At depths of 200 to 300 feet, water pressure forced approximately 400 gallons per minute through such openings. This flooding was essentially unstoppable. Submarine pumps could not handle inflow rates of 400 gallons per minute. The boat would lose depth control within minutes and settle deeper, increasing water pressure and accelerating flooding. As water continued entering the pressure hull, internal atmospheric pressure increased, raising temperature dramatically. Within minutes, temperatures inside the submarine could climb above 200 degrees Fahrenheit. This superheated air seared the lungs of crew members, rendering them unconscious and then dead even before the submarine reached crush depth. The combination of uncontrollable flooding, rising internal pressure, increasing temperature, and inexorable descent to depths beyond the hull's structural limits meant that a submarine struck by even one Hedgehog projectile was almost certainly doomed. Survivors of Hedgehog attacks were rare. The weapon's contact detonation eliminated the gradual escalation of danger that depth charge attacks provided. With depth charges, submarines might survive initial attacks, suffer progressive damage from cumulative explosions, and eventually be forced to surface when damage became overwhelming. Hedgehog attacks tended to be immediately catastrophic or complete misses. The binary outcome, total destruction or no damage, reflected the weapon's precision. Either projectiles struck the submarine or they didn't. There was no intermediate state. This characteristic troubled some naval commanders who preferred depth charge attacks' cumulative psychological effect, but the statistics were undeniable. Hedgehog's 1 in 5 kill rate versus depth charge's 1 in 60 rate meant that convoy escorts could protect more shipping with fewer vessels. In the Atlantic battle's brutal arithmetic, efficiency mattered more than psychology. Every U-boat destroyed was one that couldn't attack convoys. Every escort vessel equipped with Hedgehog represented multiplied anti-submarine capability. The weapon also allowed tactical innovations impossible with depth charges. Escorts could coordinate Hedgehog attacks more effectively than depth charge runs. Multiple ships could fire Hedgehogs at a single contact without interfering with each other's sonar tracking. This coordination contrasted sharply with depth charge tactics, where multiple ships running depth charge patterns created sonar blackout conditions that prevented tracking. Hedgehog's silent misses preserved sonar contact, allowing immediate follow-up attacks by the same ship or coordinated attacks by multiple escorts. USS England's 12-day hunting spree illustrated these tactical advantages. When multiple escorts attacked the same submarine, England's crew could observe other ships' attack results through sonar without losing their own contact. If USS George or USS Raby missed with Hedgehog attacks, England could immediately position for its own attack without waiting for disturbed water to settle. This rapid-fire prosecution of contacts maximized the probability of eventual success. Some submarines, like RO-105, survived over 20 Hedgehog attacks before finally succumbing, but the escorts never lost contact long enough for the submarine to escape. The Pacific Submarine War differed significantly from the Atlantic Battle. Japanese submarines emphasized fleet operations and supply missions over commerce raiding. Japanese submarine doctrine prioritized supporting naval operations rather than strangling enemy logistics through merchant ship attacks. This doctrinal difference meant that American anti-submarine forces faced different tactical challenges than British escorts in the Atlantic. Nevertheless, Hedgehog proved equally effective against Japanese submarines. The weapon's fundamental advantage, attacking submarines while maintaining sonar contact, transcended specific operational contexts. Japanese submarine construction emphasized range and speed over stealth and diving depth. Many Japanese submarines were larger than German U-boats, with enhanced habitability for long Pacific patrols, but size made them more visible to radar and sonar. American destroyer escorts, benefiting from excellent radar systems and well-trained sonar operators, could detect Japanese submarines at longer ranges than British escorts typically achieved against smaller, quieter German U-boats. This detection advantage, combined with Hedgehog's attack efficiency, created lethal hunting conditions for Japanese submarines operating within American-controlled waters. The I-class submarines, including I-16 that USS England destroyed, were large fleet submarines displacing over 2,000 tons surfaced. These boats carried reconnaissance seaplanes, had cruising ranges exceeding 10,000 miles, and mounted substantial deck gun armament, but their size worked against them when confronted by well-equipped American anti-submarine forces. The Japanese submarine force never developed the tactical sophistication or coordinated wolfpack techniques that made German U-boats so dangerous in the Atlantic. Japanese submarines often operated independently, making them vulnerable to concentrated anti-submarine efforts like the hunting group that included USS England. The statistical record of USS England's achievements remains unmatched in anti-submarine warfare history. 6 submarines destroyed in 12 days using Hedgehog as the primary weapon demonstrated what optimal combination of equipment, training, intelligence, and tactical execution could achieve. But England's success also illustrated the importance of intelligence in anti-submarine warfare. American codebreakers had intercepted and decoded Japanese naval messages revealing submarine deployment plans. USS England's hunting group was vectored to intercept submarines whose approximate positions and missions were already known. The combination of intelligence providing targets and Hedgehog providing lethal attack capability created overwhelming advantage. This integration of intelligence and weapons technology characterized Allied anti-submarine operations throughout the war. British codebreakers at Bletchley Park provided similar intelligence advantages in the Atlantic, allowing convoys to evade U-boat patrol lines and directing escorts to submarine positions. When intelligence identified a submarine's location, Hedgehog-equipped escorts could prosecute that contact with confidence that each attack had reasonable probability of success. The synergy between intelligence and improved weapons fundamentally altered the Battle of the Atlantic's outcome. German submariners gradually recognized that the tactical environment had shifted against them. U-boat commanders returning from patrol reported increased difficulty evading Allied escorts. The window between detecting an attacking ship and experiencing depth-charge detonations had narrowed dramatically. Some commanders reported hearing propellers overhead followed immediately by explosions, with no time for evasion. German naval intelligence collected fragments and debris from shallow water attacks, eventually identifying forward-throwing weapons. But identifying the threat and developing countermeasures were different challenges. German submarine designers attempted various solutions. Increased diving depth would extend the time between projectile launch and impact, potentially allowing evasion. The Type 21 submarine could dive to depths exceeding 800 feet, well beyond earlier U-boats' capabilities. But deep diving complicated periscope observations and limited tactical flexibility. Submarines operating at extreme depths sacrificed the ability to attack surface targets effectively. Enhanced underwater speed might allow submarines to outmaneuver attacking escorts. The Type 21 achieved underwater speeds approaching 17 knots, faster than most convoy escorts. But achieving such speeds required massive battery capacity and generated noise that made the submarine more detectable. The fundamental problem remained unsolved. Once an escort achieved solid sonar contact at close range, no amount of speed or depth provided reliable escape from Hedgehog attack. German engineers considered developing their own forward-throwing anti-submarine weapons for use against Allied submarines. But Germany's submarine force operated offensively, attacking merchant shipping and naval targets. German surface vessels rarely conducted anti-submarine operations. The tactical requirement that drove Hedgehog development, convoy escorts needing to destroy submarines while maintaining sonar contact, simply didn't exist for German naval forces. This asymmetry reflected the broader strategic situation. Germany attempted to strangle Allied logistics through submarine attacks. The Allies defended their logistics while simultaneously strangling Germany through blockade and strategic bombing. The technological race in anti-submarine warfare illustrated different approaches to innovation. British development emphasized solving specific tactical problems through practical weapons manufactured in quantity. The DMWD's unconventional approach allowed rapid prototyping and testing. When Hedgehog proved effective, production scaled quickly. American manufacturing capacity ensured adequate supply. German development emphasized advanced platforms like the Type 21 submarine and revolutionary technologies like acoustic homing torpedoes. These innovations were technically sophisticated but arrived too late and in insufficient numbers. The Type 21 submarine represented genuine advancement in submarine design. Streamlined hull configuration reduced drag, increasing underwater speed and range. enhanced battery capacity, extended submerged endurance. Snorkel breathing apparatus allowed diesel engine operation while submerged at periscope depth, recharging batteries without surfacing. If deployed in significant numbers in 1943, Type 21 submarines might have seriously challenged Allied anti-submarine forces. But the first operational Type 21 boats didn't reach service until April 1945, weeks before Germany's surrender. Only 2 conducted war patrols. This delay reflected Germany's deteriorating strategic situation. Allied bombing disrupted submarine construction, material shortages forced design compromises, skilled labor became increasingly scarce as workers were conscripted or killed. The complex Type 21 design required precision manufacturing and quality control that Germany's war-damaged industrial base struggled to provide. Many Type 21 submarines were scuttled at war's end without ever becoming operational. The boats represented what German engineering could achieve, but what German industry could no longer produce in decisive quantities. Allied anti-submarine forces, by contrast, benefited from secure industrial bases in America and Britain that operated at peak efficiency throughout the war. Destroyer escort production in American shipyards reached industrial scale. The Buckley-class destroyer escorts, including USS England, were mass-produced using standardized components and assembly line techniques. Between 1943 and 1945, American shipyards delivered over 500 destroyer escorts. This production rate ensured that convoy escorts were available in quantities sufficient to protect Atlantic convoys, while simultaneously supporting Pacific operations. Hedgehog installation on these vessels was straightforward and rapid. The weapon's relatively simple design allowed quick integration into existing ships. Retrofit installations on older vessels required only modest modifications. New construction incorporated Hedgehog mounts from the beginning. By 1944, Hedgehog had become standard anti-submarine armament on American destroyer escorts and many British escort vessels. The weapon's proliferation meant that German U-boats and Japanese submarines faced Hedgehog-equipped opponents throughout all theaters. The Atlantic victory in 1943, achieved through multiple converging factors including Hedgehog, created conditions for Allied strategic offensives. With convoy routes secured, American forces and supplies flowed to Britain in preparation for the Normandy invasion. The invasion of France in June 1944 required transporting millions of tons of equipment and hundreds of thousands of troops across the Atlantic and English Channel. This massive logistical operation would have been impossible if U-boats still controlled Atlantic shipping lanes. The Hedgehog's contribution to this victory was significant but not singular. The weapon multiplied escort effectiveness, making each anti-submarine attack exponentially more likely to succeed. But Hedgehog operated within a larger system that included improved radar, better sonar, enhanced intelligence from code-breaking, increased air coverage from escort carriers and long-range patrol aircraft, and greater numbers of escort vessels. These elements reinforced each other. Intelligence identified submarine positions. Radar and aircraft detected submarines at longer ranges. Sonar maintained contact during approach. Hedgehog destroyed submarines once contact was established. The 30 seconds between a submarine commander hearing approaching propellers and Hedgehog projectiles striking his hull represented the Kaparich's culmination of years of development, training, production, and tactical refinement. Those 30 seconds were the moment when British ingenuity, American manufacturing, Allied intelligence, and escort crew training converged into lethal effect. The German or Japanese submarine commander hearing those propellers had perhaps 30 seconds to recognize that everything his training had taught him about evading depth charges was obsolete. The weapon striking his submarine from above maintained sonar contact throughout the attack, required no preset depth estimation, and detonated with devastating effect directly against the pressure hull. In those 30 seconds, the submarine commander might order emergency dive, hard rudder, blow ballast, anything to escape the pattern of projectiles sinking toward him at 23 feet per second. But the circular impact pattern, 140 feet by 120 feet, was calculated to overlap the submarine's maneuvering radius. The projectiles were already in the water, sinking toward impact depth. The escort ship above maintained sonar contact, tracking evasive maneuvers, preparing additional attacks if the first pattern missed. The mathematics of the engagement had shifted overwhelmingly against the submarine. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.